Okay, class. So, moving on to the next topic of apply electrical and electronic instruments. So, in our previous session, we discussed about analog and digital multimeters. So, we have finished our two chapters. This is now the third chapter, which is about oscilloscope. So, you can see that we are all in this course. We are only discussing about the measurement, how good a measurement should be, what are the properties of good measurement, and different types of measuring instruments, digital, analog. We discussed the multimeter. Now we are moving on to the oscilloscope. In oscilloscope as well, we will discuss digital oscilloscope and analog oscilloscope. So most of these test instruments you have used in the lab. So oscilloscope, as you know, that it is an electronic test instrument that displays the changing electronic signal over time. As you know, it is used to show the waveforms. It displays the change of electrical signal. Electrical signal means waveform signal. And if you look at the screen here, it look like a graph because there are you can see the grids, y-axis, x-axis. So on we put voltage on the y-axis and time on the x-axis on a calibrated scale. Calibrated means it calibrated mean it shows which box is for one grid box is equal to how many voltage or how many uh, seconds in time. Other signals such as sound or vibration can be converted to voltages and displayed. Basically, oscilloscope is a machine which can display voltage waves, waveforms, voltage waveforms, and you can see the behavior, how the voltage waveforms are behaving, their shape, their amplitude, time period, RMS value. So these type of things you can measure using oscilloscope. A commonly used oscilloscope you can see here on the screen. If we talk about the main parts of oscilloscope, then the main part, first one is the display where you see your waveform. So and then there are some display controls. Here you see some knobs where you can adjust the intensity, focus, and other things. Power button is there. So these are the controls related to the display to adjust its brightness, intensity, focus, and other things. Power switch is also available in the bottom. Then there are some controls in this vertical slot. They are called vertical controls. What is the meaning of vertical controls? Vertical means the vertical axis here, the vertical axis of the oscilloscope is the voltage axis. So these controls here, they are for to adjust the voltage settings on this display. So first one is the position. Position means you can move the wave up and down because it is vertical control. So you can see the arrows up and down. So you can move the wave up and down. This second knob is kind of a selector switch where you can adjust the volts per division. So for example, if I adjust uh, 1 volt per division, so this wave height is 1 division, second division, and the third division is half. You can say 2 and 2.5 divisions. So I will say my wave amplitude is 2.5. It is 2.5 volts high. So if your wave is not coming onto the display, you can increase volts per division so that you can see it on the display clearly. Sometimes the wave is out of the screen because it is too big. So you can make adjustment using this knob to bring it within the display. Okay. Then there are horizontal controls which are here. Horizontal controls, they are doing the same thing which I explained for vertical controls, but they are adjusting time scale. The vertical controls are adjusting voltage scale, which is on vertical axis. Horizontal controls are adjusting time scale, which is on y-axis. So y-axis here. So first one is to adjust the position of the wave, left or right. Then the time, there is a selector switch, adjust the time per division. You want to make one division equal to 1 second or 500 milliseconds or whatever. You can select from here. And then there is a third slot of controls, which is called trigger. Trigger, there are different uh, trigger options available. Trigger, the main function of the trigger is to make the wave which is on display, to make it stable so that you can see the wave clearly. Okay, and if sometimes you see that the waves are repeating in a very fast motion and you are unable to visualize them clearly. So trigger controls allows you to stabilize repetitive waveforms, and they can also give you provision to capture a screenshot of the waveform if it is a digital oscilloscope. So if there are too many waves, fast moving, high frequencies, so you can use these controls to make the wave look stable and clearly visible on the screen. Right. So, and there are some more slots available here. Here, the oscilloscope comes with a cable, the connecting cable, the probe. You can see the probe here. This probe, you basically, sometimes it comes with a clip. You connect it to the circuit, and there is a ground clip to ground the oscilloscope. So this other end of the cable, you put it into the slot here. So that's how you connect this cable with the oscilloscope, and from the other end you touch it to the required position of the circuit from where you want to check the waveform. So that's how you use the oscilloscope. So this is in general, I have just given you the idea about how to use the oscilloscope. The more practice you will get once we get back to the lab and you will use it practically, then it will be more easy for you. Now we will quickly compare the digital and analog oscilloscope, same like we previously compared analog and digital multimeter. So analog oscilloscope, as you can see this picture here, this is the analog oscilloscope, and you must have seen a similar model in our electronics lab with this type of handle in front. You can rotate back this handle on top to pick it up as well. So this is the analog oscilloscope. Analog oscilloscope and digital oscilloscope, both machines function the same. It's only the provision of extra features which digital oscilloscope is offering you, but analog oscilloscope is not offering any additional extra features. But there are some advantages of analog which digital don't have. So we will look at it one by one. It has higher bandwidth and writing speed. Higher bandwidth means it can cover a wide range of frequencies, while the digital has lower bandwidth and writing speed. Analog has no digital memory. So digital memory means like your mobile phone has digital memory, computers, laptops. So they have digital memory. You can store some information, some instructions in them. Analog don't have. While the digital oscilloscope has digital memory capable of infinite storage time, means the waveform behavior which is being displayed on the screen, and at the same so for example you are testing a circuit and you are changing some parameters in the circuit, and at the same time you want to see how the waveform changes on the oscilloscope. So digital oscilloscope can do the screen recording because it has memory, so it can do the screen recording, what's going on the screen, how the wave is changing, how the parameters are changing, and you can review them later on for your reference. But analog oscilloscope do not has this recording feature and saving feature. It do not have that because it don't have memory. So analog, it cannot operate with a constant CRT refresh time, while the digital is higher resolution because of analog to digital converter used in it. CRT means cathode ray tube because the analog oscilloscope is made of cathode ray tube. It is the same technology which was used in old televisions. If you remember, uh, when this LED TV or LCD TV were not in the market, before there were used to be old TVs which were bigger in size and depth. They used to have cathode ray tube, and on that you used to see the picture. The same cathode ray tube were used in the oscilloscope to display the uh, waveforms. So it it cannot operate with the refresh time is not available. I mean the refreshing rate, the sampling per minute or second, it was not able. The analog oscilloscope was not able to modify that sampling rate. How many samples, how many readings and measurements you want in 1 second time. While on the other hand, the digital oscilloscope, it has higher resolution because of analog to digital converter used in it. Digital oscilloscope can give you a prevision in 1 second time how many samples you want to take. The more samples you take in 1 second time, the better measurement and better display it will show. The similar like the more like when you buy TV, you the salesman, if he tells you that there is a full HD TV and ultra HD TV. So what's the difference? That full HD TV is giving you a certain number of sampling rate samples in a 1 second time, or the resolution or the quality of the picture is so and so pixels per inch. But if let's say it is 1 million pixels per inch, is assume that it is samples per second in for oscilloscope. While the ultra HD TV, he will tell you it can take 2 million pixels per inches. So its quality, it's giving you quality picture, and it is more in-depth detailing in that. So same like in digital oscilloscope, it can sample, you can modify, you can change, you can increase the sampling rate. So it's giving you advanced feature. So in analog, it is not capable for operating in a look back mode. Look back mode means same like if there is something in recording, you can look back. So but analog cannot do that, but digital can do that. You can operate in look back as the waveforms are being recorded. So analog, it uses cathode ray tube for display, while the digital use LCD for display. Analog are big in size, digital are small in size. Analog are expensive because of the kind of technology they're using. The cathode ray tube is expensive, and while the digital is using LCD, which is cheaper, and overall its cost is less than the analog one. So this is a brief comparison of digital and analog oscilloscope. Let me stop the recording and open questions.